Welcome to the series. This is where we learn how to build custom AI agents with the latest large language models like OpenAI's GPT-4o, etc., Langchain, LangGraph, Langsmith, and Python. This is the second part of our LangGraph-based chatbot building using the state graph workflow. In this video, we take the chatbot graph we built in the last video and enhance it by adding a conditional node, a Tavily search-based tool node, and of course, what is a chatbot without memory, right? So yes, we add chat memory to our graph with SQLite Saver and Memory Saver from Langchain. Finally, we test the whole thing by running the chatbot graph. Now let's get started. All right, so let's focus on installation here. These are the libraries we're going to bring in. You notice it's exactly the same set as the previous video or part one. Only thing new coming in is this guy right here, LangGraph Checkpoint SQLite. And this is the guy who's going to go ahead and help us add memory to our chatbot. And here, if you can take a look, I kept it very simple. Simply the environment variable, and you can just paste it in and run this and you're on. We are done here, and as you can see, we're running the latest Langchain version 0.3.4. All right, so we are done here, and here is something I keep just for testing, just to make sure everything is working. A very simple LLM invocation. So let's see if it replies, and it does. Everything is functional. So right now we are ready to get started with our Tavily search. All right, so this is Tavily.com, and this is supposed to be the latest and the greatest search API to be used with LLMs and RAG-bots. And I especially like this because of this free tier. They allow us to send up to 1,000 requests per month for free. That's why I went ahead and opened my account and collected my API key from right here. Now let's go back to the project. All right, so here we're going to first start by installing this Python library, Tavily-Python. All right, we're done. All right, so let's get our first search done right here. Let's import the Tavily client from Tavily, and using that by passing the API key, to create a client, and with that client dot search, we pass a query election 2024 USA, and then we take a look at the raw response. So let's see what raw comes up. All right, so this is what it looks like, and now let's focus on just the results, and using pretty print here. So let's see. Okay, now let's go and have a better look. This time we're going to just isolate the titles and the URLs. And by default, it gets me 5 articles. These are the titles and these are the URLs. With that done, let's have an advanced look at the function structure. So here we are just client.search, and we are passing a query within that function as an argument who is running in election 2024. Search depth is advanced. Max result, we're asking for 7. Images true, answer true, but the raw content false, right? So let's look at just the raw response here. All right. Now, let's change it. Just focus on the results. And now let's go just focus on the answers. Okay, so let's run this. Look at that. Nice little answer. Almost feels like it is actually using an AI behind the scenes, right? But they're not claiming that. I went through the documentation. So they even have a better function right here a Q&A function, right? Even more simplified. Like here, a client.Q&A underscore search. And in the query, once again, we provide the same question and see what the result comes. And boom, very precise and concise answer. And that should be enough about the Tavily search. Now let's focus on how we can get it to work with our LLM. All right, so this is where we begin. We all are familiar with Chat OpenAI, and here we form a query. Where is Joe Biden now? And as a response, we're gonna invoke the client.search function with our query, max result 5, depth advanced, and we're specifically asking for the results variable, right? So let's see what response we get. All right, not so bad. Okay, so let's move to the next step. Let's set up our LLM with prompt. So here we bring in a chat prompt template. So as our, and this is where we create the template, letting our AI know that he's a research assistant, right? Now, template, it's you are an AI, a critical thinker, research assistant. Your sole purpose is blah, 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 blah. And the information you will receive, the response means this response right here. Right, let's do that. Okay, so this response, we actually send it as a prompt variable, and then we also provide the query, and in here build the prompt with chat prompt template, pass this template, and we format the template by assigning values to those variables. Response equals response, query equals query, and finally we create our LLM with Chat OpenAI. As the model, we use GPT-4o. Finally, we do an LLM invoke to get the result and pass formatted prompt. This guy right here. Let's print out the result. There you go. Now created a nice little report for us as a researcher, as a research assistant. All the, the main points, conclusion, introduction, etc., etc. So now we are going to go do the same thing, but this time we're going to use the OpenAI's prompt structure. This is mainly because if in case somebody's coming in who's just familiar with OpenAI's API, so and I just wanted to show that Langchain actually offers us nice little helper function like convert OpenAI messages. So even if we write our prompt in the style of the OpenAI API, as you can see, it is still using that structure, role, content, etc. But we're still maintaining the same variables, right? Even if we build it this way, we get to convert that into Langchain's messages by using this function. So let's run this. And right here, that's what it looks like. You can see system messages, etc., etc. It actually converted the whole thing with the LLM answer. Search results and everything, and into an LC message, which is basically Langchain messages. So now you get to take that LC message and once again call Chat OpenAI with GPT-4o and invoke with that message. So let's run it, see if it works. And remember, this time we are using the search results also, right? So LLM now taking that same search result and creating a nice little information-based research report for us, which has a title, introduction, and a whole bunch of important point analysis and a conclusion. With all that being done, now we know what Tavily Search is and how to use it with our LLM. All right, so in the process of enhancing our chatbot, we're going to first create the tool. Langchain has a nice little wrapper for us, Tavily Search results, and we are sending max results 3 as an argument, and we're going to go ahead and create this tool. All right, And now we're just going to test the tool, the same query as before, see if it is functional. Always test everything before you try to use them with in a graph or an agent, etc. Right? So looks like it is functional, and it is getting us 3 good results that we asked for. With that being done, we can go ahead and rewrite our new graph. All right, before we get started creating our graph, let's go back to a diagram. All right, here all the agents or functions are called a node. For example, in this structure, in a LangGraph architecture, all the functions or agents are called nodes, and all the nodes are connected via 2 types of edges, conditional edge or normal edge. A normal edge is simply maintains the linear flow between 2 separate nodes, and conditional edge, on the other hand, can take a request from one node and then acts like a traffic cop and redirect the traffic to other nodes based on that condition. And we also learned about tool node, which an agent or a node can use according to necessity and gets to invoke it and receive the results, and based on the results prepare its answer, send it back to the user. And another reason I brought this graph up again is because this time you're going to see how we create a conditional edge, and we're going to be adding a tool node. With that, let's go back. All right, so this is pretty much the same graph we built last time, but this time we added a bunch of things to it. Now here, these are the usual imports: the state graph, annotated, type dict, the add messages, chat OpenAI, etc. But these 2 are the new ones. Here we are bringing in the Tavily search results wrapper created by Langchain community to create our tool, and then to create tool node in our graph, we need tool node and tools condition, bringing in from LangGraph.prebuilt. Now, just like before, we just create a type for our state using annotated, and this will be a list of messages. And the function it will use is called add messages, which we got from here, which we'll keep adding to this list throughout the graph. And now we create this graph builder object by invoking state graph class, passing a state as argument. Now this part is new. Here we are actually creating the tool using Tavily search result wrapper with a max results argument of 3. We're asking for 3 results, and then we're creating a tools array and passing that tool in there. At this point, we are going to have only one tool. And then using Chat OpenAI and model GPT-4o, temperature 5, we're creating our LLM. Here, we're taking our LLM and using .bind tools and passing that tools array and creating a LLM with tools object. With that now, we just augment our Chatbot function. Last time we just called in LLM.invoke. This time we're doing LLM with tools.invoke. This is another edit to our previous graph. And now that the function is ready, we're adding that as a node, Chatbot. This is the name of the node, and this is the function. And this is another newly added part. This is where we're creating our tool node for the first time, using the tool node function from LangGraph prebuilt, passing the tools argument and passing our Tavily search tool here. And immediately we are adding it to the graph by using graphbuilder.addNode tools tool node. Here is another new one. For the first time, we're introducing a conditional edge. And to build this conditional edge, we are adding our chatbot node and adding this tools condition as a function. This is another one we brought in from LangGraph. So this function will help decide whether or not our chatbot needs a tool usage or not. Next, we just add a normal edge between tools and chatbot, and this normal edge will basically reconnect the tools to the chatbot, completing the full circle. And finally, we just set up a starting point. Our starting node would be chatbot, but notice this time I disabled the finish point. The reason being, in our last graph, only node we had was our chatbot node. So we had to specifically tell our graph that this was our starting point and this was our ending point. But this time, we're not going to need that because of our conditional edge. To explain that further, let's go to a diagram. So last time, this is what happened. We had a start node, and then chatbot, our single node, and then we had to specifically tell the graph, hey, this is also our end node, right? It was a very simple graph. This time, on the other hand, we have a starting point, and then our chatbot node, which is the main node. And with that, we're adding a conditional edge, which helps it decide whether or not to use a tool and where to go to use that tool. And once that reaches it, invokes the tool, then our normal edge kicks in, gets the result, sends it back to our chatbot, completing this full circle loop. And the main reason we no longer need to specifically mention an endpoint is because as soon as the need for tool usage ends, our conditional edge automatically turns into an endpoint, thus finishing the whole flow of the graph. With that, let's go back. So finally, we just compile the whole thing and create a runnable sequence called graph. Let's do that. And as we saw before, I mean, this doesn't really tell us much. For that, we just use the same function we did before to visualize it. And look at that. This time, it's a little bit more complex. Before, all we had was start, end, and chatbot, and now we have a tools node loop attached to it. So finally, it's time for us to go back and run our chatbot again. All right, so we're back to our chatbot. We actually had no change to this one. Similarly, we have this infinite loop taking in user inputs. And to break out this loop or end the chat session, we use either a quit, exit, buy, or queue. And then it breaks it out, telling us goodbye. Otherwise, it keeps going and keeps invoking our runnable sequence graph. And so when I say runnable sequence, that means you can either do .stream or .invoke, right? And as messages, as user message, we're just sending the user input. And by looping through, since this is the stream, we're going to have to loop through the event.values, which is basically the answer coming back from the stream by the LLM, right? That's the answer. And in the end, assistant's answer, we're going to display that by displaying the last message in the list, denoted here by -1 .content, that will give us the exact answer we're looking for. Let's run this. All right. So as we remember, last time when we asked a question, who's running in this USA election 2024, the answer was Joe Biden, because he had no idea about what's happening in the world because it had no internet connection, right? So this time we're going to ask the similar question, saying, who are the presidential candidates in 2024 USA election now, right? So let's see. Enter. Okay, using the internet. And there you go. Donald Trump versus Kamala Harris. This time, it gives us the accurate answer, current answer. But here's the problem. Let me ask it, tell me more about this without mentioning what this is. Watch what happens. See, now it's asking me, could you please provide more context, blah, 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 because it does not know what this is. And that's where we're going to need to add memory. so that it remembers what we're talking about. That's coming up next. For now, let's say bye, and we get out of the loop. All right, to get started with the adding memory part, we just have to install this LangGraph checkpoint SQLite. Probably already installed it up above, but I don't remember, so I'm going to do it again anyway. So next, let's go grab those libraries, SQLite Saver, Memory Saver from the LangGraph libraries, and use this SQLite server dot connection and passing argument as a memory. And then, now that memory is built, we just add that to our graph that we created before, graph builder.compile. This time we're putting in checkpointer equals memory saver. Let's run this. All right, now let's go back to our chatbot with memory. This time we have to add a little bit here. I mean, exact same code as before, but only thing we have to add here is the configurable thread ID equals 1. But we gotta have a thread ID so that it can remember things, right? And this is our previous code. We're still streaming. Besides our user message, user input, we just added config equals config. This guy right here with a thread ID of 1. That's all. So now let's start. Hi, I am Rambo. All right, so how I can assist you, right? So now let me say, does my name ring a bell? And I'm not mentioning that again. See what it does. Oh, there you go. Yes, the name Rambo is quite iconic. Mostly blah, 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 fictional John Rambo, Vietnam War, Sylvester Stallone, etc. So that means it remembered my name clearly. Now let's ask the same question again. Oh, sorry. Basically, who are the presidential candidates 2024 election now, right? Same question. See, and collects the info and gives us the right answer. And now just to test the memory, I'm going to ask a follow-up. Please tell me a bit more about them. Once again, I'm not mentioning who is them. So let's see what it does. There you go. Donald Trump and Kamala Harris, and all the details, a little bit more that I asked. So this completes our LangGraph based chatbot totally from beginning to end with tool node, conditional edges, and memory. With that, we say bye. Until next time, please subscribe and like, and thanks for watching.